Here we're going to use our crazy skills with exponents and logarithms to solve some equations. We are going to emphasize the natural log and e as the base pairing of exponential function, logarithmic function, because these are very commonly found in the physical sciences. In this equation, we are trying to solve for x, which means we need to scrape away everything that's in our way as we try to proceed inwards towards the x. So the fact that it's an equation that has this weird e thing in it is pretty irrelevant to start with. We just need to dig our way into the x. The first thing that needs to go is the minus 4. So as we would if there was anything else in this spot out front, we're going to add 4 to both sides. And so that will give us 5e to the 3x equals 10. If we're trying to dig our way into the x, the next thing that has to go is the 5. So we divide 5 from both sides to give e to the 3x equals 2. To keep digging in towards the x, the next thing that needs to go is the e. Now we can't just divide both sides by e because this is now an exponential structure. It's not just multiplication directly. But we've seen that like x squared and square root are inverse pairs that you can use one to eliminate the other. When we have an exponential expression with a given base and we want to eliminate the base and have everything else just drop down by itself, we apply the appropriate logarithm. The logarithm that goes hand in hand with e is the natural log. So we are going to apply the natural log to both sides, right? We are in charge of this equation, and if we want to apply a natural log to it, then dang it, we can apply a natural log to it. We just have to remember to do it to both sides. The entire purpose of applying that natural log is that the natural log and the e eliminate each other, and the survivor is the 3x. Now, the natural log of 2, don't go calculator happy here. Just keep writing it as natural log of 2. It's a perfectly good number. It's happy the way it is. Don't go making it into a decimal and ruining its self-identity, okay? Just leave it as natural log of 2, like you might leave square root of 2 as square root of 2, okay? Leave the numbers alone. Let them be. To solve for x, we're just going to divide by 3. And maybe on the right, I will write it as 1/3 natural log of 2, just so it's a little bit better to look at. And that will be our solution for x. Now, okay, if you want to get calculator happy and go find out the decimal version of that number, I'm not going to stop you, but this is the exact and best and most perfect representation of that value. Here we have an equation with a natural log in it. Okay, fine. The fact that there's a natural log getting in the way of our variable for the moment doesn't matter because we haven't gotten to it yet. We got to dig for the variable, which is this a. The first thing that has to go is the 9. So we are going to subtract 9 from both sides to have 6. Natural log of a plus 3 equals 24. Digging our way into the a, the next thing that has to go is the 6. So we divide both sides by 6 to give us natural log of a plus 3 equals 4. And now we divide both sides by the letters ln, right? No. People will do that. Don't do that. You cannot just divide by an operating symbol. In order to remove the natural log, we have to apply its partner that wipes it out, which is the exponential function. Just the reverse of what we did up here. So what we want to do to eliminate a natural log is raise both sides to the corresponding base. If this is equal to this, then certainly e raised to this is still equal to e raised to that. So we're maintaining the integrity of the equals sign, and the reason we do that now is that the e and the natural log, they fight it out. It's a tie. They eliminate each other, and we're down to a plus 3 equals e to the 4th. Okay, e to the 4th is like natural log of 2 up on top. It is what it is. It's a number. It's happy the way it is. Don't go calculator crazy and start cranking out decimals. Just leave it. Subtracting 3 from both sides. There we go. That is the exact most perfect form of the answer. If you would like to see what the number is, say on a number line decimally, yeah, e to the 4th is going to be a hair less than 3 to the 4th, so this is a pretty big number. But e to the 4th minus 3 is the best way to write it, and that is the solution to that equation.